if we think about innovations in material science and we focus on sustainability, how do you think advancements in energy systems or energy storage, solar technologies, maybe sustainable construction materials, how can all of this help reduce our footprint? Because clearly that's one of the challenges, and we're moving at a great pace here. So maybe Eva, I can start with you.
Oh, okay. Okay, so I come from the world of atoms, and that means that I actually look at the atoms, I see what they are and how they are placed. And the reason why I do that is because each atom has a role. And so when we are working with these materials, we need to be clear on what kind of function is it that we need to have from the materials, and then design them. And we have that ability to design material, actually have that control on the very atomic level. So I would say that we need to understand how materials are working. I come from the materials side, and then design them so that we have that sustainable aspect in these complex materials.
So that's starting out trying to make perfect stuff.
That's true.
We already have a lot of stuff. And so we need to deal with some of that as well in terms of how we want to be sustainable. We talked a little bit this morning about learning from biology, and we think about autophagy where the body basically sort of consumes proteins and makes new proteins. And we have to look at that for the globe as well. Ben, what are your thoughts about this? How can any innovations transform the industries and help reduce this environmental footprint?
Okay, I mentioned already recycling this morning.
Yeah, that was you that said that. In fact, you are the man.
I think, honestly, we can learn a lot from Mother Nature there, because if you realize that what biology does, but that's not only about recycling materials, but also making new materials and new functions. My colleague here, is in energy materials, and so think about your solar panels. 30, 40 years ago, we didn't have those materials. Now almost every roof of a modern building has a solar panel made from silicon. Can you imagine? You take silicon, sand, basically, that's it, and you make a solar panel, and the efficiency of these solar panels, let me make a blunt statement, I think this is a really, really important success of science. Your solar panel on your roof is 10 times better than what the green plant does with the solar energy. The efficiency is way and way better. Yeah? That is an accomplishment in material science. The same, I think, with new materials. Making smart materials. We are currently involved in a program together with colleagues around the world to make self-cleaning materials, self-healing materials, materials for information storage and retrieval, materials for, say, new batteries for the future, for energy storage. Getting energy is one thing, but to store energy, long-term energy storage is one of the big issues, of course, in this world. And then, finally, let me emphasize, we have been I'm a chemist, I'm a material scientist, like this fellow here. We have for the last 100 years been extremely successful in making things. How to make things strong, that it does not fall apart, look. But now, to make it recycling, to make it strong, but then easy recycling. This is a completely different perspective how we approach things fundamentally, and that is a real big challenge for all of us.
So that's been transformative, actually.
Absolutely.
In terms of the mindset.
It will be transformative, and we have to learn how to do that. We were simply too good to making materials. Now we have to see how we can do it even better, but then in the context of reusing.
Ben pointed to you, so do you want to jump in?
He is the expert.
Okay, so first of all, I'm the only social scientist here in this panel.
That's okay.
It's okay. Please bear with me. So I'm an environmental economist. So I want to point out that social sciences, like economists, can play a role to pursue sustainability. That's my standing point. But regarding the question that Jerry pointed out, I want to make 2 points. First of all, the advancement of energy storage is very crucial for achieving sustainability and climate change, carbon neutrality. We have solar panel already, right? And we have strong wind powers. But the problem is that the timing of their generation and the consumption do not match. So when we need the solar power, the electricity in the night, we don't have a sunshine. So we need a strong energy storage. And if the material scientists can come up with energy storage at lower cost, we can live without carbon emissions. So that's, I think, one challenge, the opportunity that we're looking for. We are relying on the scientists. The second perspective is the material science can help to create that can absorb CO2. So one example that the Japanese construction company is working on is that they created the concrete that absorbs CO2. So they have developed the concrete and they started to implement. And the cost is still high, so it's not into the market yet. But I think there's a possibility like that. Yeah.
Mm-hmm. Okay, great.
So, Ben encouraged us a lot, and I would like to follow a little bit. Chemists are great, actually. They can make anything.
Thank you very much.
By the way, I'm a chemist also.
I know.
Yeah, and I think the recycling phase is changing now. It's not just recycling to the similar material, but as Ben suggested, the recycled systems will be replacing some fossil resources. And the point is that the materials which is already existing is energetically very stable. So in order to change this material to other thing, we have to input energy. And if we have enough hydrogen, chemists can make anything. And I think almost all the processes are all well known at the moment, but how to make it more efficiently is some problem. And at least we need to input energy into it, so we need much more energy for this, and hydrogen. So very simple way of telling is that we need energy and hydrogen, and the chemist will transform any recycled materials to whatever that we want in a new function.
I'm not sure anything, but we try our best.
Yeah, it's very rough
Sure.
drafting. So recycle sounds very smart and nice, but you have to input energy and hydrogen. So we have to think about producing these things. And if you think about the energy that's coming to the Earth, only the energy from outside our planet is solar, and within our planet is the rotation of our planet, which is the wind, and some of the geothermal and all these things are not old knowledges that we have for a long time. And so we need a new technology way of thinking, and it costs. So economists has to think about how to balance between the cost and the sustainability, and maybe Arimura-san may have something to say about it.
Can I?
Sure.
Okay, so economics tell that actually market can help find the least cost options. So if we have an appropriate market of new technologies and new materials, the market will find out the least cost solution. But to do so, we need a price on the environment. Economics thinks that environment is not free, but we are using the environment as if it were free until now. So now it's time to price the environment. And if we price the, in the context of climate change, if we price the carbon proper way, we can solve the issue, with innovation from scientists and corporations working to make it, products, and consumers can choose the right product. Okay. So that's the basic idea.
All right, there's clearly, you want to jump in, Eva?
Yeah, I was thinking about one thing, and that is that the cost that is associated with recycling is actually a question of what the quality is of the recycled material. I'm coming back to material now. And also what is happening now is that we are learning how to actually work with more impure materials. Because when you have these impurities, they actually have a role also. And if you understand that, well, then you can lower the cost because you don't need these extreme purities in the new materials.
Well, how do you figure that out?
It's research again. So this is actually what is going on. I see this happening in Europe now, where they are, like Max Planck institutes, where they're starting to look into these questions. And it comes back to the basic knowledge about the correlation between structure and properties and how you design these materials.
So you talked a little bit about making new stuff, and you're talking about how do we deal with the stuff we have?
Yes.
Because we need to turn it over to some extent.
Yeah, we have for many, many years been working on how do we achieve certain properties, how do we achieve certain functions. But now we get to a stage where we actually realize that our raw materials, they have limited, they are not infinite. So we need to use what we have, and that means that we need to reuse what we already have produced. And things with age, they age. They change the properties and they are not optimum any longer. We throw them away, but we need to recycle them.
Yeah.
So we need to extract the materials and we need to work with that.
Yeah, it's just small. I fully agree. So there is one trend, to make entirely new types of materials, new building blocks, etc. Maybe bio-based, those kind of things, that you ultimately make the products that you can use to manufacture a car or an airplane or plastic or whatever. On the other hand, repurposing our current materials so that you have this plastic for this bottle. And what people do is try to functionalize it so that the properties remain, but that you can, for instance, easily use it again for a different purpose or recycle or whatever. That's not so easy, but that's another challenge, So getting more out of your current materials. Yes.
All right, I want to open this up a little bit now. So the way we're going to do this is that I'd like people raise a hand, and we have roaming microphones. We'll find you. We've got a woman with her hand up here in the front. Stand up, tell us who you are, where you come from, and your questions need to be relatively short so that we get a lot of questions in. Go ahead. You need a mic. And here it comes.
Thank you very much. I'm Zeynep Bal from Osaka University Immunology Frontier Research Center. I'm an assistant professor there. I have the question of this, we are talking about the sustainable materials, right? So we are really caring about the environment then, right? I'm right? So there is one question I have, that we have solar fields, which doesn't let sunshine to go to the soil. So there is a microhabitat there, which is really important for us. But we let them kill, let them die. Or, I don't know. Or, for example, the wind panel, wind turbines. So there are some cases that they, in the papers even, they say that they may, if they will be set in wrong places, they may hit they may give harm to the, I don't know, the birds or their flight ways.
So I think your question is, how do we embrace these new technologies but still preserve natural resources? So I think that was your question. So go ahead.
I think the energy range is different. The energy that biological media is necessary is rather in a low, we call it a long wavelength. And for the solar panels, we need short wavelengths region. So I think at the moment this is we can utilize both sides, yes. So the solar panel, if it is transparent to the long wavelengths, then probably we can do both.
But there is this living in harmony with technologies, but preserving natural resources. Mm-hmm. There is this balance that one wants to consider.
And I think that people are looking for that direction.
All right. You go ahead, yeah.
Yeah. And so in terms of sustainability, sustainability can mean many things. I'm specialized in research on carbon neutrality, but the circular economy is also important, and recycling materials, and also the biodiversity is another important element. And these, different sustainability perspectives, sometimes they conflict each other. But we can manage to balance these, by paying attention to the other sustainability objective. For the case of, wind power turbines, you can place the turbine in the places where a few birds flying. That way, we can reduce that risk that damage the biodiversity. So there are lots of efforts that we can work on to balance each perspectives.
All right, great, thank you. Other questions? Okay, in the middle, Yep, you're standing, so you.
Thank you. I'm Efrain Tamayo, senior researcher at Hitachi. So I think there has been some points about more functions on materials. And I think more functions sometimes bring more complexity on the materials and also more difficult to recycle or reuse. I used to do research on nanotechnology, nanomaterials, and I think at that structure, then it's very hard to reuse, repurpose. So, but in wind energy, for example, recycling wind turbines used to be very difficult. Now there are more materials that are easier for recycling wind turbines. Should we skip some of the steps in some of the technologies or some of the functions until we reach one that we can actually recycle? So what are your thoughts about this process?
Okay, this is a really important question. Thank you so much. Because in the field where I am in chemistry, physics, material science, complexity is one of the big challenges for the near future, you know. There are lots of new initiatives to deal with complex systems, multi-component systems, multifunctional systems, etc. And this is exactly, you know, what we have to learn. We are extremely good, for instance, in making polyethylene, simple plastic. But to make something that is functional, that has all kinds of functions that you can also reconfigure, that can adapt, all these kind of things that you find common in Mother Nature. This is not easy, I tell you, because it's a multi-parameter problem. And here also, we had earlier, there was a discussion about AI and so. That will help us, you know, to develop these systems, to use different parameters, how to find this space, what is the optimal system. And you are absolutely right. If you put in additional functionality, they will also affect the materials and affect also possibilities for reuse, etc. But this is something we have to learn. Once again, Mother Nature figured out to do that in a cell or with the materials of our body. But to use complexity, every time I go to a conference, you know, there are lectures in my field, there are lectures about complex systems. And often they are not too complex when you compare it to what Mother Nature does, but yes, we have to learn that. This is a big challenge for a lot of young people here, to work on multi-component, complex systems and to figure out how that will work in the future.
Maybe I'll let Eva in and then I'll go ahead, Eva. And then.
So, yes, and another thought is, and this is also a trend that is happening now, and that is that we who come from material side, we tend to think about the material, how to add and make it more complex. But now we're also bringing in people from humanities, also from social sciences, and also people who have other aspects of recycling, in order to not only to kind of directly look at the material, but actually consider all the different parameters and needs to be optimized in having a sustainable solution for future.
Great. Okay, we'll let you in.
Okay, so recycling wind turbine is a big challenge still, but recycling solar PV has already started. I was in France until last September, and I know there was a French company doing a business on recycling solar panels, and recycling solar panel actually has becoming a very important policy issue for Japan, and I think there will be that's a challenge. But at the same time, I think there is a business opportunities for companies to do work on the recycling of solar.
And you're nodding. Do you want to jump in?
No, I'm just agreeing what he's saying.
All right.
So we have to design, considering all the recycle process, not only to make something, but to reuse.
All right. Thank you for your question. Let's see. We'll go back behind you there. There's a gal. Yep, go ahead. It's hard because it's perfect.
Hi, I'm Wong from Osaka University. I have a question on price on environment. How is that different from putting a price on healthcare and education? Like, how do we make sure that not only the developed and wealthy countries benefit?
Do you want to answer that?
Yeah.
I thought so.
Thank you.
So, I mean, pricing on the environment, economic theory said that, when we consume goods or services, or when we produce goods, it can generate the negative damage to the environment. And so we have to pay that damage. So that's one way to determine the price level. So it depends on the damage that we are causing. In the context of carbon neutrality, we know that, so IPCC said that we should achieve carbon neutrality by 2050. So from that target, we actually run economic energy modeling and calculate how much we need to achieve that carbon neutrality. For example, to help the hydrogen coming into the market, we have to have high price to have a market penetration of hydrogen. So that's how we can calculate the price, yeah.
All right, thanks. You can move back with the microphone. There's a group of people in the back. I don't know who's got the mic. Yeah, standing up there.
First, I'm really pleased to attend this event. I am a PhD student from South Korea. Many researchers specializing in renewable energy production have been struggling due to the reduction of financial subsidies, especially the unstable situation caused by the government's impeachment. I'm also one of them. Then how can I appeal to the government about the importance of sustainability? In any case, if I want to survive, I need to receive financial support from the government.
All right. So I guess this would be more advocacy to help to communicate to politicians the importance of sustainability. Any thoughts around that? Being engaged citizens and participating in that conversation.
Maybe I want to make a remark from my own experience. I think indeed this is extremely important that we advocate, that we have to make a change. There was a lot of talk about energy and electricity. We can produce cheap electricity with solar panels, with windmills and all these things to produce hydrogen. But also there is now in my field of science a big trend to use electricity directly for chemical conversion. If you want to know how much energy is used to make a fertilizer, or to make the tires for your car, or to do steel manufacturing, to use electricity directly for those processes, like manufacturing processes, etc., that will completely change the picture, of course. So electrochemical conversions, chemical conversions, instead of using high temperatures, for instance, is a big issue. And that means that now you see universities are fighting for young professors that are experts in electrocatalysis, for instance, in our field, electrochemical conversion. So if you have a good candidate, tell me, because we are also looking for somebody. No, they are highly wanted, because people realize, certainly also industry, that maybe in 10, 20 years from now, several processes will be based on directly using electricity. And that's just one of the things we have to make clear to the audience, but also to our politicians, invest in those kind of developments.
Okay, good. You wanted to jump in again.
Yeah, I don't have the answer to your situation, but I want to share with you my experience. So I'm doing research on the carbon pricing, and I have been doing this for like 30 years. So before the Great East Earthquake, we had a heated discussion on the introduction of carbon pricing in Japan, just as European did. We are trying to introduce it, but then we had some government problem, and they couldn't solve any issues. And then earthquake happened, and nobody paid attention about climate change or carbon pricing. So several years, I was doing research, but nobody pays attention and couldn't get research funding. But I waited, and then when times comes, then after the Paris Agreement, people started to realize the importance of climate change and carbon pricing. So I think there is a difficult time for the people working on sustainability, but there will be a time that you'll have another opportunity, chances. So that's all I can say. I'm sorry.
Do you want to comment on this? Because it seems like there really is a big shift in public opinion about the importance of sustainability.
Yeah. One thing I would like to mention is that the United Nations has agreed to do some agenda for 2030. That was 2015. It was after the Great Earthquake, and I think it was a very good idea to have very easy to understand what we have to do in order to sustain this planet. The people agree to this, and I think we are on the way, but things happens. And then sometimes it degraded and it go back again. But we have to think very carefully that what we have to do at the final stage is to sustain this planet. And so everybody has to re-agree every 2 years or whatever what we have to do and what we are at the moment. And I think this kind of looking back and forth procedure is very important.
Okay, all right. Thanks for your question. Well, we've got one up here in the front, so if you can run the mic up here and...
My name is Ahmed Hawash from Egypt. I'm assistant professor and postdoctoral fellowship in Science Tokyo. My question is about the energy storage technologies and your views about the future of it. The point is material that provides sustainability and enhance the efficiency of energy storage. Thank you.
Okay, energy storage. How do we increase the efficiency of energy storage? Is really the question. And we talked a little bit about it, making sure we have the energy at the right time.
Okay, maybe I will start with a general way of thinking. So we had the lesson from ion battery this morning, and such a kind of battery is one thing. And another thing is converting the electricity to chemicals. So the hydrogen or sometimes ammonia will be a good candidate for the storage, and probably transporting it from along the sea. We need to have some chemicals that is easy to transport. And so these are the two candidates, major, and it depends on whether it is locally done or the more global size matters. Then I think we have to choose what is the answer to this. And I think for the batteries, it is improving at the moment, and it's as far as I know. And maybe converting to the chemicals is okay, but how to utilize these things is probably some questions. It's not only the scientific point of view, but probably the political or the economical point is quite important.
Eva, did you want to jump in?
I can only agree with what you are saying. And what I see when it comes to energy storage is that there are big programs on energy storage. So there is, my answer, general answer is actually research, science. Bright scientists working on this area. And it has been identified because at first it was energy harvesting, like the solar panels. But now we realize that that is not the only thing we need, also the energy storage. So, but I don't have any better answer than...
I can add to that. I fully agree. There is, of course, all these efforts around the world in new batteries, improved batteries, and there will be improvements. But also hydrogen, but the problem with hydrogen, of course, it's a gas, and it's not so easy to handle because it's pretty dangerous. Industry knows how to do that. But then there is also a lot of effort going on in liquid storage. You should not forget in Iceland, for instance, where they have very cheap electricity, they have a huge methanol plant. They produce methanol, a very small molecule with high energy density. And so ammonia is another candidate. So there's a lot of efforts in making small molecules that can replace petrol, but are made in a sustainable way using electricity from windmills and solar panels and hydrogen from water electrolysis. So yes, there is quite a lot of efforts. And several people favor actually liquid carriers because it's easy to transport, to pump, to handle, etc., etc. So yes, there are lots of efforts going on indeed.
All right, we have one question over here.
Hi, I'm Yadana from Duke NUS Medical School, Singapore. I have very naive questions. Kinetic energy can convert it to the electrical energy, right? Is there any way to convert human movement kinetic energy to electrical energy? So in that case, we can also sustain the energy, plus human can be the healthy because we move a lot.
As long as we're moving, that's a good thing, right?
Moving.
Any thoughts about that?
No, I have some thoughts about that, but my colleague also can comment on that. Of course, you can convert, yeah, you can make hydrogen, yeah, by electrolysis, yeah, using electricity to make hydrogen, and then use it in a fuel cell to make electricity again and to power your car. I'm not sure if that is the best way to go from electricity to hydrogen to electricity again, you know, because you lose a lot. Maybe there is a better way to directly use it. But yeah, you have to store it one way or another, either in a battery or in a fuel or whatever. Right. But maybe you want to comment on that.
No, I don't have.
All right, so that's still an open question.
Yeah.
All right, other questions back here? 3 or 4 rows back from the last person.
I'm Lavik from the National Institute of Environmental Studies. My question a bit related to this, how about behavioral change? I know that technology is becoming more efficient, but if we put on one more jumper instead of turning up the thermostat or jumping onto the bicycle instead of the AI-powered car, we can avoid this rebound effect using more energy than we actually wanted to. Thank you.
I guess there's some direct lifestyle changes we can make at an individual level. And here it was lowering temperatures in houses that are using bicycles. And I mean, clearly that's certainly things that we can all do to contribute. Go ahead.
So, you know, behavioral change is one way actually we can contribute to actually increase the sustainability. If we can learn how to reduce energy consumption through some kind of change of behavioral change, I mean, that's one way to do it. And I think lots of experiments show that, you know, if we rely on social norm, we can reduce by making the energy saving behavior as a more habit and you know, reducing consumption. But at the same time, I think the pricing is again one way to induce behavioral change in a good way. As you said that, you know, if we have more penetration of like energy saving goods, then people may tend to use more. Consequently, as a mass, we may end up consuming more energies. However, you know, on the usage of energy, if we charge an appropriate price, we can control that consumption. So once again.
But maybe, here's a question to you. You'd have to have this pricing on a sliding scale because you could basically then put prices at a level where wealthy people can afford it. And so you'd have to have a price that would be equitable for people's income and the lifestyle they have. Otherwise, you're separating out people by wealth. And I don't think you want that.
That's a very good question. So if we, you know, for pursuing sustainability, we want to charge high prices. But, you know, that may have severe damage for the, you know, life of the low-income people. So, you know, one way we could do is we can use the concept of like a carbon dividend. So this is the idea that, you know, government charge carbon tax, so everybody pays the, you know, certain level of carbon tax, but then the government uses that tax revenue to distribute among the people by the same amount per person. And that way, it can help a low-income household. You know, rich people get small amount, it doesn't matter, but it will be a good...
More of a sliding scale.
Yeah.
Okay. All right, we have time for one more question. So we'll go ahead here in the front.
Thank you. My name is Patricia, and I'm a JSPS fellow at University of Tokyo. We were talking a lot about sustainability and like research, how research can help sustainable solutions, but how about sustainability in conducting research? Because where is the balance between progress and how to make sustainable progress? Yeah, so I just want to hear your thoughts on that.
Okay, go ahead, Ben.
Yeah, I'm more than happy to send you an article that we published last year with a number of colleagues, making an assessment of how insustainable a lab runs, you know, at the university, our institutes. You won't believe that. You know, we all work on sustainable new solutions, etc., but the amount of chemicals we consume, the amount of gloves we use in the hospital, you know, and needles and all these kind of things that we throw away. The impact of our traveling, the energy, you know, in a chemical lab, and the same in hospitals and biochemistry labs, all the ventilation, you know, 8 times an hour. It's incredible. We were shocked, you know, to make this analysis, and I can send you this review. We have to do something ourselves, what we do in our laboratories, how we deal with that, and what we can recycle ourselves, you know, and what we throw away. The training of the students to be more sustainable. This is really important. I thank you very much for this question, because this is really important. If you all advocate at our lectures that we want to be sustainable and we want to use hydrogen or whatever, recycle, I don't know, our attitude, we should also change the way we do things in research, because we also spoil a lot.
There's a lot of emphasis now on accrediting labs and giving them what they call green leaf or bronze leaf or gold leaf.
These green leaf initiatives and so are really important. I strongly advocate that this is really important, that we also think about this.
Okay, well, we can actually get one more question in here. So who's Lara? You jumped up really fast in the back. So if the mic can get over here.
Hello everyone. My name is Nayakram, research student from India. My question is that, what are the sustainable solutions to power efficiently implantable medical devices?
Can you repeat that question one more time? I didn't actually hear.
What are the sustainable solutions to power efficiently implantable medical devices?
Okay, implantable medical devices. Any thoughts around that?
No, I don't know, but it's about the energy you said and how to do that. Yeah. I think you should, I would recommend you to read the papers of Zenan Bao from Stanford, for instance. You know, she makes all this artificial skin and implant kind of materials that are, for instance, some of these materials are powered by movement. So when you move...
That was the kinetic energy we heard about from the other question.
Yeah. So there are very interesting developments there. It's very early stage. But I'm really impressed what they do, you know, there. So that it's powered then by movement, for instance, of your legs. Or when you walk, you know, and these are biomedical devices. I'm not sure if they are in a hospital already, but they make really interesting things, you know, like skins that can do sensing, you know, and all these kind of things.
Okay. Certainly a lot more to do and a lot of room for exploration. I do want to have one last comment, and this, Eva, you and I were speaking last night about the commitment that people have towards sustainability. And can you just share a few thoughts about that? Because my sense is that people are really all into this idea.
That is also my impression, and especially the young generation. Because when I talk to my students and we have a discussion on what topic should they choose, and I realize that they are really engaged in the sustainability. They are concerned about our future, and this is something that I find gives me hope for future.
Exactly. And with that note, I think we're going to end. I want to thank the panelists here and all of you for your participation in this dialogue today. Thank you very much.
Thank you. Thank you, Ron.
Thank you.
Thank you very much.